right, on to quiz 506, create and interpret histograms. Well, histograms are very similar to line plots, dot plots, except for we now use the frequency of a range and we keep everything nice and close, and we still go up and down with it, but they're all touching because the data is going to be all included. All right, so a shopping center keeps track of the number of customers in each store. At lunchtime, the data shows the number of customers in the 15 different stores in the shopping center last Sunday. All right, there's the data. So just like a line plot, you're going to arrange it from least to greatest, and then you're going to either find a range, probably they've already created it for you, and you're going to drag on the histogram how many of your data points fit in that range. So for instance, 0 to 5, 1, 6 to 10, well, I don't know if that's it. Let's go take a look. I figured it. The way that and you're like, Mrs. Reynolds, didn't you see this? I may have saw it. That might be what popped in my brain. But also, when you are thinking statistically and you're thinking about these visual graphs, you want to think, what makes the most sense? How would I chunk all of my data to make a nice visual representation of the number of stores and the number of customers? So here we go. So each keeps the number of customers in store at lunchtime customers. Number of customers, perfect. Number of stores. All right, so the problem, the visual data representation is number of customers, there's the range. Oh, and one of the stores, that's all. So remember, you have to know how to read these, so it's always time to take time to think. Thanks for watching me think. I know that might have been like, oh, hurry up. Or at least in my head, I think like that because I'd never want to waste your time. But thinking isn't a waste of time. So I should never think that it is. So number of stores, right? That's what this is. This y-axis, this vertical axis is telling us the number of stores, and then this range is the number of customers. The histogram, that's what doesn't make sense to me, is that is the frequency of people the data shows. So that's what's not quite making sense. This is how many customers had, how many stores, oh, I get it, had. So there was one store that had about 5 customers, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Got it. 15 stores. Here's their numbers of the number of customers in their store at lunchtime. So how many stores had between 11 to 15? It says 3. That means up here in the data is going to have either between 11 and 15, there should only be 3 points. Let's see, 12, 14, 14. So there's the 3 points. Okay, between that range, between 11 to 15. Between 16 and 20, so there's 7. Let's see, 16 and 20. So 1, 2, 3, 4, 5, 6, 7. Okay, 7. Perfect. That's it. That's all we're doing. Creating and interpreting, which is what I was taking some time to do, the data. This is how many stores. 7 stores had between 16 to 20 customers during lunchtime last Sunday. That's what this graph was representing. It took me a second to read it and really think about it, not just solve it and get the right answer, because remember, comprehension is key. So the data shows the age of 8 different dogs at the park. Boom. 3, 3, 2, 4, 7, 8, 8, 10. 0 to 2, there was 1. There was 2 3s and a 4. 7, that should be, so 1, 2, 3, 1 7 and 2 8s, 6 to 8, 3. I think there was 1 10, right? So between 9 and 11, there was 1, and then there was none 12 to 14, and none 11 to 12. Oops, these are messed up. All right, look for video 2.